So I think we've explained why this is a worrisome topic and that this is something that's getting worse and not better. Are there any, is there anything on the horizon that gives you hope that maybe we can reverse this trend and get more insight into what our machines are doing and why they're doing it?
Yeah, absolutely. So if you're looking at mobile networks, mobile robots, networks of robot, like self-driving cars or self-driving drones are great examples of that. There is sort of an intermediate, middle way, I think, at this point of making the decision-making distributed, making the data collection distributed so that we do have a record of what every robot saw, what every robot did, like the version of the software that made it do that, even like the outcome of random number generators that might have gone into that. So you have that history. And then, so at this point, I think that, what gives you hope is like, if we at least have those histories in a way that maybe, blockchain helps to secure, so we have a verifiable account, then, at least we can, when we want to, we can dig in and understand what that, particular robot actually did and why. And if we want to make sure that, every robot maintains some kind of consistent and validated type of AI, that, we can make those decisions in a distributed way, but actually maybe in those cases we do the learning in a actually more central way, where you can validate a potential new personality before you roll it out to a fleet of distributed robots.
You have some kind of playpen or something that's maybe trusted where you're growing these things.
There's these ideas of robot personhood that are floating around about sort of throwing up your hands about the liability of saying, I'm just going to put a learning algorithm out there, we'll see what happens.
Right.
And I won't be blamed for what it does.
It wasn't me.
Right.
And I don't know if that's such a great idea.
Yeah,
I think that's a terrible idea.
Okay.
I don't think we're ready for that.
Right. I'll jump to Roel next because I want to ask about UI in the future for interacting with AIs and also for understanding them from a kind of transparency standpoint and looking into their psychology and what they're doing.
Yeah, I think that both for security and for privacy, transparency is key. It's a very obvious concept.
Absolutely.
If you make it transparent, then you essentially communicate what is going on.
Right.
And I think that's where a lot of things go wrong today, is that communication is not happening, partially because startups think that they have to keep everything secret, but also partially because the nature of deep learning in a connected network means you don't really know what's going on.
Right.
But if we talk about a complex system, it should still be able to communicate at some level what it had done or what it is about to do. And humans do this, right?
Yeah.
So it's called a mental model. We have these schema that predict, for example, in a panel discussion, it's going to be you asking the questions, me responding, or somebody else. So we know that this is happening. And I can also play that back. And so you can think of that as a blockchain.
Yeah.
Right? So I have a chain of events in my head that I can actually reverse or move forward, and I can communicate it to you at a level that doesn't represent the complexity of what is actually going on in my brain.
Right.
It doesn't need to, right? So a great example of this is Tesla. So in their self-driving car, they have this little icon of a car on the dashboard, and it shows just what the mental model is of the car.
Yeah.
And it communicates it in a way that corresponds to the mental model of the user of what the car is supposed to be doing. So for example, it sees 2 lines on the road, it'll paint 2 lines on the road, and it's trying to stay in between those lines. If one of the lines it can't see, the line disappears.
Yeah.
And so what that means is that now me as a driver, I can go, oh, I have to be vigilant because it might lose the other line, and then I have to grab the steering wheel.
Right.
So communicating confidence in your decisions, communicating and being able to roll back histories of decision-making, I think is critical, and I don't know to what extent that's happening right now.
Right, okay. So maybe then the user interface experience with respect to AI and trying to understand what it's thinking and why it's making the decisions that it is isn't so much opening it up and looking inside the brain and peeking around in there. It's more that it's communicating that to you, you're asking it questions, and we're interacting with it in a more human way.
Yeah, and it's a dialogic approach, even though it doesn't need to involve speech.
Right.
Most speech interfaces are terrible. It can be a diagram or a drawing, as long as it relates to what the human thinks the system should be doing or how it should be represented.
Right.
So never have an engineer design this.
Right. Very nice. So Nancy, I think that's a good lead-in to your research and what you've been doing. What can that tell us about
it is a good segue. I'm just trying to figure out how both of these ideas here relate to what I do from a cognitive science perspective, which is to study how it is that we become the kinds of agents, intelligent agents, that can reason in the way you've just suggested, in terms of, as you put it, mental models. But one of my hypotheses is that, in fact, a necessary precondition for that capacity is language itself, is the ability to use language itself. So language, on this view, really is the representational tool that we use in order to be able to do the sorts of things you were talking about. And it's important to understand, so it's a very, I feel like I'm sitting between both sides of the problem here, or both facets of the inquiry, which is at the neural level, or if you like, in an AI system at the level of a network, it looks like there are things that we can usefully talk about as representations there.
Right.
What we might call homomorphisms,
Right.
That literally, for that agent, stand in for the things that they represent. Kind of like, I like to use this analogy because it's really helpful in explaining this very specific way in which they function as representations. A train track. A train track, you might say, is a representation of a route from point A to point B.
Right.
And in fact, it can function to guide a train along that route without anything there being aware of the fact, recognizing the fact that that is the representational role of the train track, okay?
Okay.
So that's at the level of the brain and so on. But now at the level of tools, representational tools that we use, concepts, words, and so on, these things can function as representations only when, and only to the extent to which, we recognize them as stand-ins for whatever it is they're standing in for.
Right.
And the big million-dollar question is, how do those homomorphic representations at the brain level, serve, I guess, as some kind of condition for this other capacity, and what other things are required for this other capacity? Because all animals that have a nervous system have that homomorphic capacity.
Right.
Okay. But they don't all have what you might call the symbolic capacity. So,
Well, I think it's
right.
a layered approach, right? So, I mean, a horse that's been going the same route every day knows exactly how to get back home to the barn. And that's because they have a representation of the spatial map, which is probably not a language thing, but it is some form of representation.
Right.
Possibly spatial, possibly graphical. And we need to build these layers on top of the network as little meta layers that can interpret what the connected network is doing. And so you can't just have a deep learning system, you have to have a communication system on top of it. A system that reasons about the reasoning.
Right.
And that's kind of where Mind AI was going, I think.
Right.
Which I really
That's
liked.
right. Yeah. And to get back to, I guess, reasoning about the reasoning, that's a good touch point. In your work, Nancy, is there anything in particular that it's saying or hinting at about the nature or limitations of, say, privacy, security, or transparency with respect to AI in the future as we move more toward these cognitive models? That's a very broad and hard question, sorry.
No, it's okay. I think that we really need to think carefully about how we traverse this, the kind of representation we were talking about at that brain neural level or the network level, and what else is needed, the scaffolding to get to that other level.
Right.
And that's the work that I do with respect to living cognitive systems, but of course the idea transfers to artificial ones.
Right.
And I think there are going to be some, at least I'm starting to identify some necessary preconditions, and they're kind of surprising. They might not be what you think.
Yeah.
So for example, just as an example, two of them. One is an ability to learn new behavior needs to be there.
Right.
And another one is what I call, I'm just working on this idea, but fluidity, which in terms of the level of granularity of the brain now, as opposed to the psychological level, means a capacity to access one's own learning history.
Okay.
So in terms of a neural network, we might think of that as being massively, having recurrent connections, lateral connections, forward connections, as well as forward connections.
And in particular, as we move more toward a distributed model of computation, as James was saying, with agents that are out there moving around, but also exhibiting behavior that is swarm-like and maybe beyond that, where the cognitive processing is happening in a fully distributed way, they need some way of being able to reflect on the past decisions that they and their neighbors have made, which possibly is a use case for decentralized technology. That's interesting.
I loved your sort of analogy of even just the train tracks to explain homomorphism, because like what that brought, at least to my mind, was the notion of having preconditions, right? And thinking, well, what is the necessary precondition that you need to be able to do some function,
right?
And we know learning from data is hard, and you can learn from data without any privacy, but if you want to learn while respecting privacy, that's harder. Understanding what the preconditions are to be able to learn the minimal preconditions, and using that as a basis to inform what the governance should be, as opposed to what is easy to do.
And how much privacy do you have to leak
Exactly.
versus how much can you actually claw back?
Yeah.
Yeah, that's very exciting.